spot in a reactive manner, and you're documenting all those decisions in a particular template. That is architectural decisions. So what are the general architectural decisions you are taking during the designing time? So this is on left side, you can see here architectural decision must be documented using AD process. What are the decisions you are generally taking? What is a backup restore architecture used? You can either use a SAN, so storage area network, or tapes or optical devices to store your so what kind of architecture or what kind of storage you can use? Then architectural structure, either you can choose a client server model or entire system or other design layouts, means other styles, other architectural styles we learn. So which type of style you are going to use in your project? So this also another architectural decision. Then either software buy or build. You can either build some modules or you can create by your own. Buy means it's already existing one. Suppose reuse means reuse your components. Reuse components means already existing thing you can use in your project, or else you can create, you can build your own. Both have its own positives and negatives. So anyway, if it's an already existing one means you can, what is the advantage? If existing one means you can save a lot of effort and time. So that also an architectural decision. And what is the transaction support needed inside the component, and how can you, what kind of persistence mechanisms you can audit, you use for auditing, data purging and data archiving, what kind of mechanisms you can use, and what are the framework, application framework you can use, what are the communication mechanism you can use, what is the performance requirement, and how can you achieve that? All these decisions and the message passing between the components. So all the decisions you can take during the architectural decision time. So these are the these type of decisions you are taking during the architectural design. What kind of architectural styles you can use, what are the components, what is the relationships, what are the messages, the passing, what are the communication mechanisms you can use between the components for data transfer. So these, and either your software can buy or build your own, which type of client server system you can use are there, like their data informations process all are storing in different layers. So the intermixing won't be there. There's a clear isolation between all these different types of informations. That is the entire system. Client server system, you already know that. So which type of architecture you can use? These decisions you are taking during this period. So this is called architectural decisions. An architectural decision depends on your agile or prescriptive method. Agile method means on the spot you are changing many of the architectural styles. So based on that, you need to change your decisions too. You have to modify your architecture. So that is the architectural decisions. 1 second. This is the one of the architectural decision process status diagram. Here you can see when you take an architectural decision, first you have to check the state of architectural decision. One second. Okay, here enterprise architecture, or it is a non-enterprise architecture, or a cooperative architecture, or business architecture. Based on that, it will vary. So here, everywhere you have to go for a different level of review process. Minimum 2-level review process will be there. So review process means there it will check the customer whether we are satisfying the customer requirements in your architecture. So the decisions are taken during the review process. Suppose if it's not satisfied, it will after the review process, you can see here it's going back to the originator. Here RFC means request for comments, so means it's a feedback system. Again, it's going to the back of the backline, that is originator, from where the process started. So after this review process, the results may be revised, escalate, approved, rejected. Approved means that architecture is good, it's approved by the review team, and rejected means it's rejected, and escalate means you need you need to. So this are the different escalate, approved or rejected. If it is approved or rejected, whatever it is, the results you have to notify all the architects who are behind the designing or architecture development. And if it is escalate, after the escalation, again you have to escalate means it's a sudden change, right? A huge difference. So that after that upgradation, again it's going for a review team by the management. And again, after the modification, this is again revising, and this process will continue till it approved. Once it is approved, it will notify the architects directly. So this is the architectural decision process. It's an iterative process. And we are going for a review process, and in the review time we will either we will be either rejected or approved by the team, and that we need to notify all the architects, and we should keep the documents for further or future reference. So the steps actually here I mentioned. AD is created in appropriate tool. These are the steps. That diagram, the status diagram will actually represent the same thing. The AD is created in appropriate tool using architectural decisions template. And after that, and we should remember the suitable document management repository should be needed, and responsible architect. He will check what type it is. Is it a business line decision, or it's a enterprise decision or non-enterprise decision? Based on that, responsible architect will be there. He will review this architectural decision to check whether the scope is matching, and after that it's going for review body. Review body minimum 2 level. Anyway, more than 2 levels also need, depends upon the feedback. At least 2 review bodies will be there. One is CIO level. CIO means Chief Information Officer level body is there, and enterprise level. That is for enterprise level decisions, means architectural decisions, and business line its strategy is different, but anyway 2 level will be there. And after that, after the review process will happen, CEO may approve the AD, reject the AD, or send it back to the domain review body. Okay, these are the outcomes, either rejection, approval, or review. That review process may be escalated or a normal review process. Revise, a normal revise. Okay, that is mentioned here, a revise or escalate. So after that, the business line or domain review body may send it back to the originator for update if it's needed. And this process will continue. Means the domain review body is there. Again, they will accept or reject it. After the modification also, it's going for the review process. So the review process is a continuous process happening many times. So if an AD is deemed to have large impact on organization, suppose if you take an architectural decision which has very large impact on the organization, it will be forwarded to management review bodies there. It based on the impact. If it is not giving that much impact, then that review body, that level review body is not there. The IT directors, IT steering committee will be there. That is another review body. So, and state set to escalate. Review may result in approval of the AD, or it may again send back to originating. This process is same. Always going for some reviews after the modification, going for some reviews, and the results may be either accept, reject, whatever. It's like our project review. There is a chance to accept their project proposal, or else there is a chance to reject it, or else they will ask you for some modifications, and sometimes they may ask you for huge modifications also. So this is the same procedure here, not much difference, just you can relate with real-time applications, what you are doing. The next topic is architecture. Next is architectural considerations. When you take a decision, you have to take something on consideration. That is economy, visibility, spacing, symmetry, and emergence. These are the 5 points you need to remember. Economy means years of uncluttered, or the uncluttered means not packed, right? Means unnecessary details you can avoid. That is the economy. Economy in perspective architecture, not like money. It means minimalism or simplicity, or reduce the details, means unnecessary details. The economy level. Then visibility. Visibility means architectural decision and reasons for them should be obvious to software engineer. It should be very much clear. It should be visible to the software engineer. Then only he can use the same architecture in future reference. Then spacing, separation of design using hidden dependencies should not be there. So should be a separation or spacing should be needed, and simply be balanced. Architecture should be balanced. Whatever architecture we are creating, there is a symmetry in architecture, right? So that is the architectural symmetry or consistency. Emergence, it should be self-organized. Self-organized behavior and control. Then only if some problems happens, it could clear those problems by itself. So emergence should be there for every architecture they are developing. I mean, not only in software architecture, these rules, these considerations are also practical in your normal construction, building constructions also. So economy, visibility, spacing, symmetry, and emergence. And the main architectural considerations you have to look into when you are going to develop your architecture. So architectural decisions basically based on your considerations, should be based on your consideration. So this is the last topic. Once we can go through the whole syllabus. Are you listening? And listen to the class? Sheshu Kiran is okay. Sheshu. Preeti is also. Preeti and roll number 2. So very few students are listening. 9 members raise their hands. So module is a just before wind up this module, just go through the syllabus once. Design engineering. What is design engineering? How can you, what are the criteria for designing? Good design, quality design engineering, firmness, delight and commodity. And what are those quality attributes? Those definitions are there. Then what is design and who does the design and why it is important? Then how can you obtain this firmness, commodity and delight? By diversification and convergence. What is diversification and convergence? And what are the steps to achieve? What are the work products after the architecture design? And how can we assess the model? Then what are the elements of analysis model? This figure actually we learned previous unit also. And from the analysis phase to design phase, how can we translate? How can we do the translation from analysis to design? So this diagram is very important. And the same diagram, same concepts, but in another way, this is another way of representing that. In that analysis model, there are 4 different types of elements are there. Scenario-based, flow-oriented, behavioral, and class-based elements are there. So what are the categories of classifications under each different types of elements? And then next is, how can we design the how can we map the design with the work products? Different phases, analysis, design, development, testing phase are there. And the outcome is problem, model, and solution. So we can match with the phases. So design process and design quality. What is the design process? What is design quality? How can we achieve the quality? Then what are to achieve the quality, we have to follow some guidelines. What are the software quality guidelines? So every standard, okay, if you want to achieve the quality, we need to follow one standard. The standards why we are creating to achieve the quality, right? So that quality we can achieve only through some standardization. That's why every field, in software field, every field, there is a standardization process is there to make sure that's a quality product. So the quality attributes are there that are it's acronym is FERPS, functionality, usability, reliability, performance, supportability is there. So these are the quality attributes. So next is design concept. Design is very, very important topic for every. This is one sure question I can say for the final exam, your semester end exams. 8 mark or 12 mark question. This is one of the sure question from this module. Design concepts. 9 concepts are there: abstraction, architecture, pattern, modularity, information hiding, functional independence, refinement, refactoring, design classes. All these points I explained in detail. So what do you mean by abstraction? What is contradictory to abstraction? That is refinement. And architecture patterns. What do you mean by architectural patterns? What do you mean by modularity, information hiding? How it is important, the information hiding in your architecture? And what do you mean by refactoring? And what are the different design classes? How can you classify the classes according to the design? So these things we need to So in between some diagram, this modularity was software cost diagram is also very important. From this module, from the design concepts, all these points are 2-mark questions actually. Separate if you separate every single point, it's a 2-mark question. The entire design concept is a 12-mark or 8-mark question probably. Then next is functional independence. Actually you could achieve by cohesion and coupling. So what are the different cohesion, low to high, that strength? A coincidental cohesion is happening coincidentally, so it is low cohesive in nature, and this will increase, the strength will increase from left, right, and functional cohesion is the most strong cohesion, means strongest cohesion. So functional cohesion is highly recommended, and high cohesion, low cup is the good software. It's recommending. Then different types of cohesion with examples are explained. So all these cohesions also you can expect as 2-mark question. Then what is refinement, refactoring? The next is design model. Actually, design model we can view from 2 different dimensions. One is process dimension and there is abstract dimension. And this transition from these 2 model dimensions, now the process dimension and abstract dimension, how can you see the design model? So this diagram also important. The next is design model. Types of design models, data design elements are there, architectural design elements are there, interface design elements are there, component and deployment level design elements are there. So these are the design elements. Don't get confused. So when you design, you have to design these things separately. Means you have to design data, you have to design architecture, you have to design interface. All are separate. You have to design. These are called design elements, component deployment. So those details are there. Next is creating architectural design. So what are software? So architectural design. This is the last topic, architectural design. Software architecture introduction. What is software architecture and who does the software architecture and what is the work product of the software architecture and what do you mean by this is the definition for software architecture, what you're representing in software architecture, why it is important. When it comes to agile architecture, agility is one of the main factor you need to consider. Means architecture you can change according to the change in requirement. Even you should be ready to change your decisions even in the last possible moment also. And there are 6 forces can affect the agile architecture. An agile model driven development, AMDD, life cycle for software architecture. So this is the agile model driven development. And next is agile architecture process at scale, means changing here. It's, you can see here there are different model visions are there, different feedbacks are there. Based on that we are updating the architecture. So envision initial architecture, that is with your primary requirements, and then communicate architecture to stakeholders. And based on that, every place you could see here the feedback we are taking. And based on that, we will change the model vision and you can update the architecture work product. Again, you are taking the feedback, work with the developer, and the last model you are creating. The architecture, this phase outcome is not a software. Don't forget that it's an architecture only. Software is only the architecture. So what are the principles you need to follow for a good design architecture? And what do you mean architectural style? And different architectural styles are there. Data-centered architecture means a data store is there in between, and all the clients can modify or update or add or delete. Modification means always comes, and the updation means either addition or deletion. I can do in the data store directly without interacting each other. So this is called a data-centered architecture or blackboard architecture. And data flow architecture means it's like a pipeline architecture, pipe and filter architecture. Filters are the processing elements, and pipes are the one which transfer information from one place to another, one processing element to another. It may be change in the like for a best example is compiler. Either we are creating a new thing or else we change the format. So you know all the 7 phases of compiler and how all those 7 phases you can consider as a filter, and the input and output of those phases are actually going through the pipe. So next is a call return architecture. In that, main program, subprogram architecture is there, and remote procedure call architecture is there. Main program, subprogram is just like a procedural architecture where we can give the means like a call return value, like function call and return. We are defining your function in one subprogram, and you can call to the main program. So it will return the function value. So this type of architecture is called a main program. Subprogram, it comes under call and return value. And another one more is the remote procedure call that we learn in operating system clearly, that caller sent a request to the calling, means like a client server system, and with arguments. Okay, request with arguments. There are protocols there in both client and server system, and again then request and reply will come with arguments from the server. So this is the RPC mechanism, and how the message passing in RPC mechanism that you learn in detail in operating system subject. When object-oriented means it's an encapsulation of data and operations in a class. If that is the architecture format, means we can call it as an object-oriented architecture. Actually, there is no figure for object-oriented architecture in the so next is layered architecture, means we are dividing into different layers, and each and every layer has dedicated functions also. Best example is here operating system layered structure, or else you can write even the network ISO layered structure. Then architectural patterns. What do you mean by architectural pattern? Architectural decisions. Today I covered this point, architectural decisions, and what are the different types of architectural decisions you are taking while architectural designing, and what are the process flow, means or procedure for architectural decisions, and again include the theory part also here. This is same thing, only the diagram which I explained, same theory is given here just for your reference. Then architectural, what are the architectural considerations? Any doubts from this module? Next week you have an exam, right? Module test will be there. So before you have any doubts? I just recapitulated all the points once, because this was a very lengthy unit. We started some 2 weeks back, and I'm sure you people won't even open once after finishing the classes. So any doubts? Any doubts? Anybody is there? This people are completely silent. B level. Do you have any doubts?
No, ma'am.
When you are in this textbook, actually, the syllabus is according to the framework activities. It starts from the planning, communication, that entire things we called as requirement gathering and requirement engineering things that we already learned. Next phase is analysis and design that we completed in second module, and third module is about architecture designing. Then fourth module, I think it is development and testing, and fifth, I have to check that. Anyway, that is the order. Once introduction, first introduction to software engineering, process model, agility and process, just general things. The next we discussed about understanding the requirement modeling means requirement gathering. It is a requirement gathering phase. In that we discussed entire things about planning and communication and planning. Then analysis. Okay, then third module is design and architecture. The next is quality concepts, recommended approach. Means fourth module actually development is other program. So that part, development part is not there. The next is quality concepts. That is when you create a quality, when you develop a software, you have to maintain the quality. So next chapter, next unit, we will discuss about the quality concepts, and last is about testing. So same order is maintaining. Okay, different types of software testing, component integration level testing is discussing in the final unit. So we have 2 more units. So anyway, the entire order is just a framework activity. For every software development is following the same set of activities. So any doubts on this architecture? Any doubts? And one more thing, the Coursera subject. Coursera, actually I posted one Google form, right? But very few students responded. Many people are not responded. Actually, I have to submit the list of students who joined. Actually, suppose if you did not register it, you have to include that information. I just ask you about the status, means not be the person who are doing, not yet registered, or are you doing? Different status are there. Anyway, all the students will come under any of these categories. So every single person has to respond. I posted in your group, but still some 30 more students are there to respond. Do it immediately. Today I will submit the details to the Coursera coordinator. And if anyone is experiencing problem with your Coursera login or account, you have to contact your Coursera coordinator. That's why they are asking for this, that at last moment already contacted. So that what about the software engineering status that you have to enter here? Suppose if you could not able to join in your Coursera, then definitely you have to enter the status here, because I have to submit